Hello student, I'm Aman, I'm your maths teacher. I will discuss the function. Do you already know about the function? And this is our topic of discussion. I already noted that our classes will be on the topic of real function. Okay, do you know about the functions? Now the topic of the discussions are definitions, example, type of function, that is including the surjective and the injective. Okay, after that, composite function, inverse function, algebraic operation of the function, and the monotone function. This is all topic we have to cover in this class. Okay, now we are discussing about the definitions. Okay, we already know about the function in the class 12, I think so. So we are briefly describe the definitions. What is the definition of function? First of all, function is one type of mapping. We are called, do you know mapping? Mapping is just like that, this and this. There is a set x and a set y which is non-empty, that is not equals to 5, and y and another set which is called the domain and the image. Then this is a relation, that is f, we are called, this is f is a relation from this x to y, where x is a non-empty set. Therefore, we are relate the function as it is the mapping, or you can share that the relation. Okay, that is f is called a function from x, which is non-empty set, from x to r. R is a real number set, that x to r is called a real valued function on x, such that is defined as f x to r, where x is a non-empty set, such that for x belongs to capital X, f of x is a real number, or it is on the set of capital R. Okay, real number set. That means a real function which is defined from real function f, which is defined from x to r, where x is a non-empty set, such that for each small x, f of x, each small x belongs to the set capital X, such that f of x is a real number. Okay, do you get that which is a function? When f of x is called the domain or the image. F of x is image. Okay, f of x is an image. Now we are defining such an example. Such like a function f, how it is defined? It is defined from D is a non-empty set, to R, such that f of x equals to x square. You can take it, or it will be f of x equals to sin x. Anything it can be defined. Okay. Just like a function, it will be algebraic function, trigonometric function. If you define a function f of x equals to mod z, where function is defined. Now this is the first type first, and second example is f of f is defining from, f is a function from c to r, that is a complex number to a real number. Okay, f is defined as a complex number to the real number, such that f of x equals to, or f of z equals to mod z. that is the modulus of the complex number. It is defined as if z equals to x plus iy, then it can be defined as a mod z equals to root over of x square plus y square. Okay, do you get that? What is a function and how it will be defined? Where is the domain? What is the range? What is the image of the function? Okay, do you already have a clear idea about the function? Function is nothing but a mapping which is related from a non-empty set to another set. Okay. We are discussing here the real valued function. That means a function which is or it is its domain or it is range. Domain, it will be a non-empty set and its range will be a real number. Okay. Now we are taking some example where first examples. First we are taking example. We already know about of f of x is defined from R to R such that f of x equals to some f of x is equals to some constant c. Okay, that any number is defining or it's converging to a constant number c. This function is known as a constant function. Okay, a function f is defining from R to R where f of x equals to c. C is a constant, and for all x belongs to R. For all x belongs to R, it's called a constant function. Okay, we already know about another type of function f R to R where x is belongs to R and x not equals to 0, then f of x equals to 1 by x is another type of function. Such example we already know f of x equals to root x, f of x equals to sin x. These are the example of the function. Okay, clear? This is a square root of function. This is a trigonometric function. And if we take another function f of x equals to mod x or absolute value of x, this is a absolute function. Okay. We already described here the definition of the function and as well as the example. Okay. Now we are going to the topic, that is the properties or the type of the function. Here we are discussing the two type of the function, that is injective function and another is surjective function. Okay, you already know that is a 1-1 function and onto function. Okay, so first of all you have to be a clear idea about that what is a domain and what is a range. Then we are discussing about the image, we are discussing about the injectivity property and the surjectivity property. That is nothing but a on and onto function. Clear? Now, first of all, we are discussing the injectivity property. I'll remove it. That is the injective function. Injective function. Okay. First of all, injective function, that is f is defined from D to R, where D is a non-empty set and D is called the domain of the set. An injective property is also known as a one-to-one. I already said that is the injective function is also known as a one-to-one function. Okay, where injective function is the property defined that x1 and x2 belongs to D, where x1 not equals to x2, implying that f of x1 not equals to f of x2. That is clear? If D is a domain of the function f, where f is defined D to R, the real number set, where x1 and x2 belongs to D with x1 not equals to x2. That means x1 and x2 both are distinct. Clear? This two distinct number is implying that the f of x1, that is the function of x1, and the function of x2 is also the distinct. Clear? These two functions is also distinct. So this property is called the injective property. If the function follows the property, that is called the injective function. Now we are taking some example. Such example, just f of r to r such that f of x equals to x. Okay, it is also an injective function, because if x equals to 2 and x1 equals to 2 and x2 equals to 4, then f of x1 equals to 2 and f of x2 equals to 4. Both are distinct. Okay, clear? This is a previous example. We are taking that as a simplest example, f of x equals to x, which is called the injective property. Okay, if the function follows the injective property, that will be a injective function. That is also called a one-one function. And next we are changing to the property of surjectivity. Okay. That is a surjective. Surjective function is also known as onto function. Clear? Surjective function is also known as a onto function. How it is defined? The defining of a surjective function, if f of function is defining from D to R, okay, D is a non-empty set and it is defining the domain D to R, then if E is any subset of R where E is the range of the function f of x, okay, then we are called that if D to E is said to be surjective if f of D, that means the domain of the function is, that means f of x of the function is equals to E, where E is a subset of R. That means if the function, here it is the function, this is x to y, okay. If all x are going to y, if there is another y, small y belongs to capital Y, then f of x is a subset of y, not the whole y, okay. There will be the extra numbers in y. This y, that is the f of x, which is subset of y, we can define another set which is subset of y, that is z. Then f of x, it is equals to z, is also known as a surjective property. That means ki there will be a subset which is the range of the f of x or the function of x. Then we call this function is surjective, or this function is onto. Clear? we are taking an example. If the f of x equals to sine x, okay, f of x equals to sine x, and f is defined from R to R. Therefore, how it is the function will be defined? If we take two numbers pi and 2 pi, then f of pi equals to 0 and f of 2 pi equals to 0. Two distinct number pi and 2 pi, both are converging to the 0. Therefore, the function is not a injective. Okay, it is not a injective function. Okay. Now we are checking that it is a surjective or not. Because we have to check that the function have the range is, what is the range of the function? Range of the function is sin x defined, sin x is -1 less equals to sin x less equals to 1. That means total function f of x, where the function is defined, f is x belongs to R, the number x belongs to R, -1 less equals to x less equals to 1. Then this is all because of that the function is this is the range of the function, and it is not the subset of the this is the range of the function, and this is not the subset of the R. Okay, that's why this is not a proper subset of the codomain set R. That's why it is a proper subset. It's not a proper subset because all subsets are the totally R subset is -1 less equals to, not a proper subset to the R. That's why it is not a surjective function. Therefore, f of x equals to sin x is not a one function, is not also a onto function. Okay. Now we are taking some example of equal function. Second one is restricted function. What is equal function? A two function f and g both are defined from D to R, where D is a non-empty set and R is a real number set. Both are defining the D to R is called the equal function if f of x equals to g of x for all x belongs to D. That means for all number which are taking from the D, for all x belongs to D, f of x equals to g of x. These numbers are called these functions are called the equal function. Real valued equal function, we also call this. This is a real valued equal function. Such type of example we are taking f of x equals to mod x and g of x, where f and g both are defining from R plus to R plus. That is the positive real number set to the positive real number set. G of x equals to x such that x greater than 0, because we are setting that f and g both are defining from R plus, that is the positive real number set. Okay. Therefore, mod of x, that means a modulus value of the R, which is also a positive value for x greater than 0, because we are taking D as a R plus, that is a positive real number set, and G is also taking x, where x is greater than 0. Therefore, both of the domain are same and both of the function are same. Okay. These are functions. These are the example of a equal function. There is also a function that is root over of 2x and 2x whole to the power half. This is also a function which is both are defining on another way. Okay. Now this is a restriction function. What is the restriction? If we defining D is a subset of R and D is a subset of R and D0 is a non-empty set which is subset of D, then F is function defining to D to R and G is a function which is defining from D0 to R, then Fx and Gx both are said to be then only Gx is set, Gx equals to Fx. If Gx equals to Fx in D0, then G is said to be restricted to F. That means if D is a subset of R and D0 is a subset of D, then F is a function is defined from D to R and G is a function is defining from D0 to R. If G of x is equals to F of x in the domain D0, then we call that G is denoted by, then G is denoted where it is denoted by F by D0. Okay. That means G is restricted, the function is restricted to the D0. Okay. These are the two types function. Next one is composite function. Composite function. If D is a subset of R and F is defined from D to R and G is defined from E to R, where F of D is a subset of E is a subset of R. Okay, it will be a proper subset also. Not to be not only the subset, it will be a proper subset. That is, F of D is a proper subset of E and E is a proper subset of R. Then we called a composite function. Composite function is defined